Hi everyone. Today we're going to study how to graph linear inequalities in one variable. First, let us see some symbols for inequalities. The first is the symbol more than. The second is the symbol less than. Now, the third symbol is more than or equal to. The fourth symbol is less than or equal to. Let us have some examples, and these are true statements. 7 is greater than 5. Next, 2 is less than 3. Next, 7 is greater or equal to 5. Next, 2 is less than or equal to 3. Next, 7 is greater or equal to 7. Next, 2 is less than or equal to 2. Let us note that on the number line, the lower number is placed on the left side of the higher number. Let's have an example. We have the number 5 and number 7. We know that 5 is lower and the 7 is higher. So the 7 is placed on the right and the 5 is on the left. Now, let us learn how to graph linear inequalities in one variable. We will follow two steps. Step 1, draw the number line and look for the reference number. Step 2, identify the solution set based on the given inequality. Let us have example 1. Graph and give the interval notation. We have here x is greater than 3. It means we want to identify all numbers that are greater than 3. Take note, it is not equal to 3. Some examples are 3.001, another is 3.2, next is 4, another example is 6, another example is 10, another is 200, so on and so forth. So to write this on the number line, we're going to first identify the reference number. Our reference number here is the number 3, and we can see that the number 3 is here. So all numbers that are greater than 3 are found on the right side of the number line after the 3. But take note that since number 3 is not part of the solution, we are going to put a hole on top of the number 3. Next, for the interval notation, we're going to put the solution set and we're going to write the endpoints of the solution set. Take note, the first number that we're going to write is the lowest. So in here, the number 3 is written here, but since the numbers greater than 3 are unlimited, so we put this symbol infinity. Now, we're going to use the parentheses, and that means the number 3 is not part of the solution. Also, every time we have infinity, we will always use a parenthesis. Let us have example 2. Graph and give the interval notation of x less than or equal to 1. Let us give examples. The first example is the number 1 itself. Because of the symbol less than or equal, the number 1 is part of the solution. Next example is 0.5, then 0, then -3. Another example, -11, also -150, so on and so forth. So on the number line, first let us locate the reference number, and that is the 1. The number 1 is here, and all numbers that are less than 1 are those numbers that are going to the left side. So we draw a blue array here going to the left side, and this is going to -infinity. Take note also that since 1 is part of the solution, we put a solid dot on top of the 1. So for the interval notation, again we're going to write the solution set. Let us start from the lowest number up to the highest number of the solution set. So on the left side, it is coming from the -infinity. That's why it is used here. And with the 1 as the highest number on the set, it is now placed here. Now, we use square bracket after the 1, which means 1 is part of the solution. This is the general form of inequalities with its corresponding number lines and corresponding interval notation. We have here 4 types. This is the first, this is the second, the third, and the fourth. On the first, we have here x is greater than a number a. So on the number line, we identified first the a, and then all numbers that are greater than a are going to the right side of the number line after the a. And for the interval notation, we put first the a, comma, and infinity, and then the left parenthesis because a is not part of the solution, and we also put parenthesis after the infinity. We take note that all the time for the infinity, we always use a parenthesis. For the second type is the x greater or equal to a. Again, we identify our reference number a, and then all numbers greater or equal to a are those numbers that are on the right after the a, and this is again unlimited. Take note that a is part of the solution, so we put a solid dot on the a. For the interval notation, we copy the a and the infinity, and we use the square bracket. For the a, it means a is part of the solution, and after the infinity, we put the parenthesis, because for the infinity, again, we always use parentheses. The third form is x is less than a. The reference number a is here, and then all numbers that are less than a are those numbers that are on the left of a. And this is going to -infinity. And also, on top of a, that this a is not part of the solution, we put a hole on the a. We start with the lowest number, and this is never ending, so we put the -infinity. Again, we put the parenthesis every time there is infinity involved, comma, and the a follows with this close parenthesis, which means the a is not part of the solution. The fourth type is x is less than or equal to a. This time, the a is part of the solution, and all the numbers that are less than a, so it is going to the left side. And on top of a, we use the solid dot. For the interval notation, we put parentheses every time there is infinity, and this is negative infinity, comma, and a with a square bracket. And that means the a is part of the solution. Let us have example 3. Graph and give the interval notation of this x greater or equal to -3. First, let us draw our number line. Let us identify our reference number, and that is the -3, so it is here. So all numbers that are greater than -3, so those numbers that are on the right, going to positive infinity. But because of the greater or equal sign, the -3 is part of the solution. We put a solid dot on top of the -3. So for the interval notation, we use the square bracket and then the -3, because the square bracket denotes that this -3 is part of the solution, followed by comma, and all numbers that are going to the positive infinity, we use infinity and the close parenthesis, because every time there is infinity, parenthesis is used. I hope you learned something from this video. See you again next time.